Hey everyone, welcome to this lecture. In this lecture, we are going to start our discussion for Palo Alto acting as a SSL forward proxy firewall. Now, before I go ahead and show you the configuration, how do you set up a Palo Alto firewall for SSL proxy and SSL forward proxy setup, and what is the meaning of it? Let's go ahead and discuss the basic principle of what is SSL/TLS inspection is and why do we need that. So this is one of the important area that many people find it quite difficult to understand, and it is kind of confusing for a lot of people. So let's simplify that and make SSL TLS process understandable for each one of you. Okay, so for that let's take a notepad and let me explain you the various process involved over here. Okay, so the topic is SSL/TLS process. Okay, so the term SSL stands for secure socket layer, TLS stands for transport layer security. So basically, over here we'll try to understand how a browser which is taken from any of, let us say, a client device and a website which is at a destination end. So if the client is willing to communicate to any of the web server, okay, how that communication happens over a secure connection. So to make it simple, let's take up a diagram here. So let's say I have got a client PC and I have got a web server. Okay, I've got a web server running, and this is connected over internet. So I have internet sitting here, let us say some ISP router or some ISP sitting here. Here we go. So this is my, I can say, end user. Okay, it is running some sort of browser. For example, could be Edge, could be Firefox, could be Chrome, etc. Okay, and let's say this is my destination web server, which is running internet based application. Example, let's say zbnetworks.com. Okay, so this is your ISP through which you can route your traffic to the world of internet. And of course, we'll have our firewall sitting in the middle and all those stuff. We'll discuss those things later, but yeah, at a very beginning, at a high level overview, we'll try to understand how the browser of this client user or the end user and the website that is hosted by this web server, that is zbnetworks.com, how a secure connection, we can provide a secure connection for privacy and data integrity for communication between the server and the client. So when we browse an HTTPS based website, okay, so basically the idea is if the user is trying to browse HTTPS : and give the FQDN, which is zbnetworks.com, that this word HTTP and HTTPS, so HTTP is clear text and HTTPS, but the word S is where the SSL encryption is taking place for this particular session traffic, and whatever data you send across this session from the client to the destination web server, all this data will be encrypted, right, using this SSL process. Now whatever payload, whatever data you send on this particular session, every communication, end-to-end communication will be encrypted. That is the whole idea, right? So SSL/TLS, what is the job is it normally encrypts the payload in the session. That is the job. Okay, now The browser is going to create an HTTPS secure connection using a process called as a one-way SSL handshake, right? The term is one-way SSL handshake. So the browser is going to form HTTPS secure communication with the destination server using one-way SSL handshake process, and we'll discuss that later. I will tell you what is the meaning of it. Okay, and we can leverage Wireshark tool also to understand the various approaches or the various packets that gets exchanged during this SSL/TLS handshake process. All right, now just to give you a quick idea, what is TLS stands for. So the TLS stands for transport layer security. Let me just write down some points over here. So TLS stands for transport layer security. Let me take up another notepad and write some points over here. TLS, as I'm telling multiple times, it is transport layer security. Okay, the predecessor was basically called as SSL, right? So it is an encryption protocol which is designed to secure any internet communication. So a TLS handshake is the process that starts this secure communication session that will use the TLS encryption technique. And during this particular TLS handshake, there are multiple processes that will occur between the client and the destination server. So the various processes that is involved over here are the TLS handshake process. So this is TLS handshake process. The first thing first is the client and server will exchange messages to acknowledge each other. All right, the messages would be basically client hello, server hello. All right, and we'll discuss that. I'll show you some Wireshark packet snips, and I will show that to you. Hold on for that. Then they will verify each other's identity. That is important. Okay, and then establishment of encryption algorithm. Establishment of encryption algorithms they will use for securing the data plane messages will be decided. So which encryption algorithms to be used will be decided at this stage, and client and server will agree upon a session key to be used for encryption. Okay, all right, so if you don't understand this particular process, I will make it very simple. So the whole idea is, the main purpose of this SSL handshake is to provide privacy for any communication that is happening between a server and a client. So when I say any communication, it means HTTPS based communication, right? Web based communication. And during the handshake, the server and the client will exchange important information which is required to establish this secure connection, right? And there are two types of SSL handshake that can be possible, right? So SSL was the old term, and the new term is basically TLS. So just in case, so there are two types of SSL handshake can be possible. I will just tell you two types of SSL, or you can say TLS handshakes are possible. So first thing first is called as one-way SSL. It means only the client will validate, only the client will validate the identity of the server. Okay, so when we browse any HTTPS based websites, usually the one-way SSL is going to take place, where the client browser will validate the identity of the website or the destination web server. Okay, and second one is called as two-way SSL. Two-way SSL, as the name says, here what will happen is both the client and the server will validate the identity of each other. Okay, and usually it is happening, it will be a process for server to server communication, where you have two-way SSL being used. Okay, now if anyone asks you what is the difference between TLS and SSL, is very simple. Okay, so keep it very short and sweet. So TLS is actually it is just a more recent version of SSL. Okay, so as I've told you, SSL stands for secure socket layer. If anyone say you that TLS versus SSL, so you can say that TLS is a more recent version of SSL. Okay, SSL, as I've told you, it is called as secure socket layer, and the reason TLS was developed because it is going to fix some security vulnerabilities which the earlier SSL protocols was having. So SSL 2.0 was first released in Feb 1995. Okay, which was basically so SSL 1.0 was never publicly announced. So it started from SSL 2.0 because SSL 1.0 during its development phase and the testing phase itself was having a lot of security issues. That's the reason it was never publicly released. So although this SSL 2.0 was publicly released, but it also contained some security issues and quickly replaced by SSL 3.0 in 1996. So SSL 3.0 was introduced in 1996 as a replacement to SSL 2.0. Then in the year 1999, the first version of TLS, which is called as TLS 1.0, was released, and this was thought of an upgrade to SSL 3.0. Okay, since then there have been more than 3-4 TLS releases, and the most recent release was there in August 2018, where the TLS version announced was TLS 1.3, and that is still the latest one. Okay, so ensure that if anyone asks you when does a TLS handshake occur, so basically we will encounter in a TLS handshake whenever we search for any website that runs over HTTPS protocol. So any client, if they are trying to browse HTTPS based websites, then this TLS handshake will happen. Okay, so what happens during TLS handshake, as I've told you, so during the course of a TLS handshake, the client and the server will do certain things. So first thing first is specify which version of TLS they will use. right? So in case of TLS handshake process, okay, first thing first, they will decide is specify which version of TLS they will use. Okay, second step will be decide on which cipher suites they will use. So negotiation for cipher suites algorithm will take place over here. I'll show that to you in the Wireshark snip shortly. Hold on for that. And then third step would be to authenticate the identity of the server's public key and the SSL certificate authority digital signature will take place here. Certificate authority digital signature will take place here. And last but not the least is to generate the session keys in order to use symmetric encryption after the handshake is complete. Okay, so these are the different process which happens for TLS handshake. Yeah, so when you look for a common output, of your let's say I've got a user, who is trying to browse any URL. So first thing first, the user will search for www.zebinetforest.com. It will go and look for DNS query. Once the DNS gives him a response, then it finds out the IP address of that particular destination URL. It goes in contacts there, and it will find out, the communication process begins. Then the TCP communication process will begin from the client to the destination, right? So this is how the traffic patterns kind of look like. So if you look into this more carefully, where you notice one thing that I'm showing you here, exchange of couple of IPs. So you can see that I've got a source IP of 192.168.0.104 right here. Just give me a second. So this is the source IP. Okay, this is the destination IP of certain web server, and you can see that the TCP three-way handshake process has begun. So first packet is a SYN packet, then the destination is returning back to the sender SYNAC packet. Okay, and then the source is sending to the destination the acknowledgement packet. So here the TCP three-way handshake process gets completed, and then the TLS handshake process starts. And first thing first is client is going to send a hello packet. So here you can see the client is going to send you can say a TCP hello packet, right? And to the destination IP, the destination IP acknowledges that, and then the destination IP will send back its with the server hello message, right? So you can see that, and you can see the certificates, the server key exchange are happening over here. You can see that the cipher suits are getting exchanged over here, right? So the whole idea is, at this particular stage, the client hello, server hello takes place, and the exchange of certificate and session key takes place, right? Understanding which algorithm of cipher suit they will use will take place at this stages. All right, so first thing first is a client hello. So that I will show it to you how a client hello looks like. Just give me a second. Okay, so this is how a client hello packet generally looks like. Okay, so you can check that the handshake protocol over here, it is client hello, as it is stated. So the client sends a message to the server saying that I would like to set up an encrypted session, and here is a list of cipher suites and the SSL TLS version I'm willing to use, and I'm also sending my public key, which can be used by you, Mr. Server, at a later point in time, right? So you can see that the TLS version I'm exchanging right here. You can see that there are 46 different cipher suites that I have are listed over here. It's a client hello, right? All right, so the whole idea is it is in the above. So in this particular message you are seeing that the client is sending the hello with TLS version 1.2, and by this the client will notify the server that it has its support for 1.2 version and below versions as well. So it will also send the list of the cipher suites, that is 46 number of cipher suites as I've told you, and out of this list the server is going to select a particular cipher suite that the server will support. And if the list contains cipher suite that the server does not support, the server will ignore those ciphers. Okay, and if any of these cipher suites were found not to be supported by the server, then a failure alert will be sent and the server will close the connection. Suppose I'm sending 46 cipher suites, none of these cipher suites are actually supported by the destination server, so it will send back a failure and it will close the connection. Okay, so likewise you have something called as you will have something called as a server hello, right? So let me show it to you how a server hello generally looks like. Just give me a second. Okay, here we go. So this is how generally server hello packet generally looks like. You can see the handshake protocol is a server hello right here. So the server hello, it says to the client that hey Mr. Client, let's use this particular cipher suite from your list, and I also checked that I can use your TLS version, so we are good to go, and here is my certificate which includes my public key, right? So along with the server hello, the server is sending the certificate of the server with the certificate chain. The certificate chain will be validated by the client against the client trust store, and we can see the log of the certificate sent by the server as well. Okay, so the thing is the TLS version that it has agreed for, the protocol type, you can see the cipher suite that it has agreed for, right? The session ID over here, and this is basically the different types of the hello messages, right, that is in place. So you can see that TLS version 2 record layer, it's a handshake protocol, and it's a server hello. Okay, likewise the client will verify the server certificate and it will extract the public key, right, that the server is trying to tell the client, right? And the client will use this public key to encrypt any data, right? And using the private key which my server is actually keeping, the server can go ahead and decrypt that particular data. Okay, so private key is kept by the server, only the public key is exchanged, and using the public key, then you go ahead and create the session key, right? So both the client and the server will generate the session key from the public key, right? And yeah, then when both the client and server is ready, they will tell that my handshake is complete, and using that particular session key the data encryption will take place, right? So I believe you understand the points listed here regarding SSL/TLS, right? So the whole idea is how does the process happens and what are the important parameters you have inside those details, like for example client hello or in server hello. Okay, now let's say when we go to this Palo Alto firewall, so when we go to the Palo Alto firewall GUI, you can make this Palo Alto firewall to act as an SSL proxy device. Now first thing first, why we need SSL. You need to understand, that if my user is sending any traffic, through the firewall to the world of internet, and my point is, if this traffic is sent as clear text, that means the firewall can see the upload and the download of the payload, and the firewall can understand what is the contents that the user is trying to send or trying to download. Then accordingly this particular firewall can take an action, right, if it is found to be a vulnerable file. But what if this particular user is trying to send any traffic through the firewall to the internet, but that traffic is encrypted? So if the traffic is encrypted, that means the firewall is not going to see any content of the payload. So the payload, whatever data you are trying to send, that payload will not be visible by the firewall, right? So if it is an HTTPS traffic, as we have discussed, so in HTTPS session, what happens is, the client and the destination server over here will do an TLS handshake process, figure out a particular session key, and using that particular session key, the data will be encrypted, right? The data will be encrypted and it will be sent across the session, right? And if this particular firewall is unable to decrypt that particular data, then it will not be able to understand the payload contents behind it, right? So if the user is trying to upload or trying to reach a destination server which is a malicious server, or if it is trying to download some content which is a malicious content, so in that case it is very difficult for that particular firewall to understand if it is if the packets are encrypted. Okay, so it is very important that the firewall sitting as a man in the middle component should have the capability of doing SSL decryption, right? Should have the capability of doing SSL decryption and should have the capability of understanding the payload of that encrypted session. Okay, so there are two things that can happen. First is when you do SSL decryption on this particular firewall, and so two things can happen. Let me just tell you that. First thing first is where just a second. So when you think of SSL decryption on, let us say, firewalls, okay, first thing first, you need to understand that it will be doing, or it will be creating a server certificate from itself, right, which should be trusted via or by the client browser application. Now the certificate which the server will generate, the client will be actually using that particular firewall certificate. So basically it is creating a server certificate, but this is actually created by the firewall. So the firewall is going to create this firewall certificate from itself, which will be trusted via the client browser application, right? So you are going to have the second point is it will go and maintain two separate session. Okay, the first one is from client to firewall, will be one SSL session, SSL/TLS session, and the other one is from the firewall to the destination web server. Okay, so this is also a separate SSL/TLS session. So the firewall is going to maintain two separate sessions, okay, one from the client to the firewall, this is one session, one SSL session, and from the firewall to the destination device, this is another SSL session. So whenever the server, the firewall generates a certificate, that certificate could be either self signed by the firewall. So in lab environment you can define the self signed certificate, or you can actually use some sort of CA server, right? You can use some CA server and you can go ahead and get it signed via a valid CA server, and then push that particular certificate to the client. And in the production environment, normally you will be using group policy updates, so might be using AD to deploy that particular server certificate to the user browsers or the client browsers at a trusted root certificate authority store. Okay, so that particular certificate which the browser will now have will be trusted by the browsers when they are trying to do some HTTPS based communication, right? So basically now there will be like client will go and talk over an SSL session with the firewall, right? The firewall will intercept that particular traffic. The firewall will intercept that particular traffic, and when the traffic is intercepted, then the firewall will be using the backend server certificate which he has received. The firewall is going to recreate the session with the server certificate public key and send that client data over that particular session, right? So it will have two separate sessions, okay, one from client to firewall and one from firewall to backend server, acting as man in the middle proxy. Okay, and there are, you can see there are three types of SSL proxy what it is supported in Palo Alto firewall. So three types of SSL/TLS supported. One is called as SSL proxy, right, which is also called as SSL forward proxy, or you can say SSL outbound proxy, right? Then is inbound SSL, and one is called as SSH proxy. Okay, they are almost similar stuff. Okay, so the first case first is in case of SSL proxy, also called as SSL forward proxy or SSL outbound proxy. What happens is the client sits in the inside zone. The client sits in the inside zone, and from the inside zone the traffic will hit to the firewall inside interface. So I've got a firewall sitting here, say this interface 1/1, it is also part of the inside zone, and the firewall has an interface 1/2 which is connected to the world of internet, and this is your outside zone, right? So when the communication is from the inside zone to the outside zone, when the communication session starts in the inside zone and the destination is on the outside zone, and the firewall is going to do the decryption of your SSL encrypted packet for this direction traffic sourced from inside zone and destined to outside zone. In that case it is called as SSL proxy or SSL forward proxy. Okay, on the other hand, let us say if I have got a firewall sitting here, right, and I have got a server, I've got a server sitting here, and the server is sitting in the demilitarized or the DMZ zone, and the firewall has got connectivity to the world of internet, and I've got a user sitting here on the outside zone. So I've got a client or a user sitting here on the outside zone, and the firewall has a DMZ zone. So say interface 1/3 is part of DMZ, 1/2 is part of outside zone. Okay, so the traffic is initialized from that outside user. That outside user traffic is initialized from it, and the traffic is destined to that DMZ zone. And for that particular purpose, if the firewall is doing the SSL decryption of this particular packet, then in that case it is called as inbound SSL. Okay, so it all depends upon the the direction of traffic flow, right? So if the traffic has been sourced from the outside user destined to the DMZ, In that case, if the firewall has been configured to do the decryption of SSL communication, right, if it is an HTTPS communication, in that case it is called as inbound SSL. Similarly, we can use another process where you can decrypt the content for SSH, right. That means, let us say I have got a firewall sitting here, and I have got a user sitting on the inside zone. I have got a server sitting on the, let us say, on the DMZ zone. Imagine that way. So I've got a server on the DMZ, I've got a user on the inside. If the user is trying to do some SSH, if the user is trying to do an SSH connection to that particular server sitting on the DMZ, then in that case, the firewall, if I give him the capability to do run the decryption for SSH based communication, in that case the firewall will go ahead and be called as an SSH proxy firewall. Okay, so you can use it for multiple cases as I've shown here. Now just to make it clearer, so what you do is you go to the Palo Alto firewall. Okay, so I've logged into the PA firewall 1 GUI here, and the first thing first is to enable the Palo Alto firewall for doing SSL decryption. Your job is to go to the device tab, and under device tab you find that there is certificate management section. Under that you can generate the certificates, right. So click on that certificates option over here and click on generate. So when you click on generate, you can just give a certificate name. Let's say I'm giving the name as PAFW1 for ZBN. Let's say my certificate common name is also same, and it's a local certificate. I can sign this particular certificate via an external CSR if I want it, but I'm doing it for my lab purpose, so I'm signing it by myself, so I act as a CA. So the Palo Alto Firewall 1 is itself acting as the CA. Likewise, you can continue, you can work with OC SP responder as well. You can change this cryptographic setting, so you can use RSA or elliptic curve. So let's say it being RSA, and it supports 512 to 4096 number of bits for doing the encryption. If you take more number of bits, the CPU and the processing power taken by the firewall will be also high. Okay, so the different digest amplified also different digest algorithm, it is SHA varieties over here. So you can say SHA 256. Every certificate will have an expiration date, so let's say I keep it for 365. And also you can add some certificate attributes based on a requirement. You can add country, you can add state, right, you can add some department, right, and you can enter those values based on your requirements. So country is India, state is Mumbai, department is security as an example, right, and you can generate this particular certificate. Now the certificate attributes, whatever you have listed, this one, so the country, the state, etc., this is all optional if you are doing it for the lab purpose. All right, so now your certificate has been generated. Now your job is to click on this certificate name and you allow this options for lab purpose, right. So you allow this as a forward trust certificate. The certificate is a trusted root CA, and for lab purpose only this middle option is clicked, that is forward untrust certificate, but in production environment this middle option, that is forward untrust certificate, will be unchecked. So click on OK there, and next job is to create a decryption profile, right. So when the user is trying to send some traffic to the world of internet, right, so ensure that I have the Palo Alto firewall with a decryption profile or a decryption policy created, so that it can go and decrypt this particular user traffic. So to create the decryption policy, it is like click on the policy tab over here, and you can find that under that policy rules already you have got a security policy in place which allows the traffic for internet access from trust zone to untrust zone. You can see that, and any application from this respective subnet is allowed. So internet is allowed here. So I can click on this decryption over here, and I'm writing the decryption policy. Okay, so let's add a decryption policy. So name, say this is my decryption policy 1. Okay, source, let's say source is my trust zone. The source address, let's say it's my LAN 10.1.10 subnet, any user, any device. Destination is where I'm going to the untrust zone, destination address being any, and service or URL category. So for which service you want, for which URLs you want decryption to happen, right? So service is basically, what port numbers. If you have any custom port numbers, you can also define it. Okay, and I'm defining here for any URL category, but you can also make certain URLs to be exempted from doing SSL inspection, right? For example, if you are trying to go to some sort of financial website or any sort of government websites, right? If you want to allow my firewall not to decrypt that, it is called as SSL exemption, right? So normally used for finance category URLs, health category URLs, then defense category URLs, any government category URLs, right? So generally you don't want your firewall to do decryption of those URLs listed under the category of finance, health, defense or government. And so this is under the organization risk and compliance policies. In that case, you need to define those URLs by clicking on this add button, right, and exempt that not to get decrypted, or exempt that from getting decrypted. All right, so this is where you can write down over here any SSL exemption policies. Okay, so normally if you add, let us say just for example, any finance category URL, so you can just go to the option over here and you should say no decrypt. Okay, you should say no decrypt. Okay, so here what I'm doing is I am deleting that. So service, as of now I'm decrypting for all types of category just for lab purpose, and you can see that my action should be decrypt, and my type is, as I've told you, I've got 3 types that I can make my Palo Alto firewall to work for. One is SSL forward proxy, that is used for inbound to outbound connection. SSH proxy for SSH communication, decryption can happen. And SSL inbound inspection, that means decryption can happen for traffic originating from the outside and destined to the DMZ zone, right, generally. Okay, and you can also log it, and you can also forward the logs to any external syslog servers. All right, so click on OK there. So decryption policy is done. Yeah, so you have got your certificate created, you have got your decryption policy created. So now your job is to commit it. Okay, let's commit all the change. So once the configuration gets committed, what you can do is you can go to this particular Windows client, or let us say this Windows server device, and you can access the management interface, right, of the Palo Alto firewall, so using HTTPS, and just log in and download the certificate and install it inside your Chrome trusted certificate authority store. Okay, and then when you go ahead and when you test that connectivity to any internet resources, you will see that you are going to use the Palo Alto firewall certificate which you have just now generated, and that certificate will be in use. All right, that means that your traffic has been intercepted by the Palo Alto firewall 1, and it is doing the decryption for you. All right, so just a second. All right, so you can see that is my server VM, right? From the server VM, I am logging to the Palo Alto firewall over HTTPS. Okay, now my job is to go to the device section. So in the device section I can go ahead and look for the certificate, which I could normally, normally the certificate will be pushed to all those inside clients, either via group policy updates or via some sort of Microsoft Intune. There are multiple mechanisms of pushing those to the browser, right? Okay, so now your job is to select that particular certificate, and you can say export certificate. But here, just for the lab purpose, I'm like I need to get the certificate at my end, so I'm like trying to access this management IP of the firewall. Usually we'll not do that in production, but just for the lab purpose I am doing this. Okay, so I am exporting the certificate, and there are multiple methods that you can choose, either PMDER or PKC. So let's say it's spam, that is by default. Click on OK there, and the certificate has been kept it, right? It has been there. So if you open that certificate, it is there. Okay, so now your job is to go to that Chrome extension. So you can go to the Chrome settings by clicking on the three dots. Okay, you can search for certificates, so it will be there under security. So when you scroll down, you can see manage device certificates option here. Click on that, and then click on this trusted root certificate authority, and you can see these are the different trusted CA that my browser is trusting. So now you can just import it. Click on next, browse for the file name, okay, which is there in the downloads folder. This is the cert. Okay, let's click on next, and I am placing that in the trusted root certificate authority store. Click on OK, click on next, and click on finish, and click on yes to that, and the import was successful. All right, so now you can open up, let us say, a incognito window and try to access, let us say, for example, facebook.com, and you can see this connection lock symbol over here. Click on that, click on connection is secure, click on certificate is valid. It says from DigiCert, but it takes some time. Sometime it will take a bit of time for this to happen. Okay, commit is done. Let's try to do it once again. Let's say I refresh the page, still it is showing as the DigiCert certificate. Let's say I go to some other URLs. Twitter is now called as x.com. Okay, so you can see that the common name has been PAFW1ZBN. So this is the certificate I am using, right? So similarly, Facebook should also be there using this certificate. Now sometimes issues arises with Meta, so there's a reason. Yeah, let's try with YouTube. You can see Twitter is using our, to reach Twitter, the client is using the Palo Alto firewall certificate, and Palo Alto is able to decrypt it. Let's say for YouTube, what's happening? YouTube is also using that. Okay, so we'll test it out. For certain URLs there might be some dependencies, that is a reason. All right, but yeah, let's say for one of the website or a couple of websites is happening. Next, for verification, what you can do is you can go to the policy, right? Sorry, you can go to the monitor, okay, and under traffic you can actually go ahead and verify, right? So whether an SSL decryption is taking place or not. Okay, you can see that, and also you can check this option called as decrypted option, which will be by default unchecked. So check on decrypted action. Okay, so you can see that some packets, if it is getting decrypted, it will show it to you. right? For example, you went to certain twitter.com and the packet got decrypted, so it was shown as decrypted as yes. Likewise, you can see that in your policies, you have made a decryption policy, and the decryption policy you have got a hit count, so you can see that you've got some hit counts for that decryption policies as well. Okay, so SSL decryption is taking place. Likewise, you can also view it under the session browser information as well. Okay, so you can also check that if the decryption has taken place for certain URLs. All right, so yeah, I believe you can understand that what is the meaning of SSL encryption, how does it take place, and the theory behind the scene, how to make the Palo Alto firewall to work SSL proxy device, and do the basic lab. So I hope it is clear. I will leverage this for our upcoming contents as well, an upcoming discussion of your Palo Alto firewall topics. So please practice it. Thank you so much. I will see you in the next section.